And just moving on, I guess it'd be nice to find out a bit about the solution, the actual sort of makeup of it, the component parts, and maybe as a sort of follow on how it might work, you know, in a particular app, you know, the sort of process, how it actually works for the end user.
Sure. So Pulse Zero Trust Access, or PZTA, is a cloud delivered service, and it follows the Cloud Security Alliance's software defined perimeter architecture. So it's a client-initiated SDP solution. And the way it works is typically you have three components. You have a a controller component, and the controller houses all the policies. It's the brains behind allowing all the connections. It essentially keeps track of all the users, what they're requesting access to, all the verifications of those users and their devices and the security posture. It aligns those attributes with what is the policies to allow them to have access. And then it also understands the infrastructure and the other components that allows for a connection between the user and their device and the actual application. So that's what a controller does. And the controller for us is hosted in the cloud. In fact, we have our controller system hosted in Azure. And this is a multi-instance, multi-tenant, microservices-based solution. So it's built from the ground up to deliver this cloud security. The second component is something called a gateway. And the gateways essentially are virtual appliances. They're distributed they're distributed by the customer, the enterprise, and they're placed closest to the application that users would want to get to and that organizations want to defend. So the gateways can be placed on-premise, they can be placed in a private cloud, they can connect in means for public cloud as well. And so the gateways communicate to the controller. The third component is the PZTA client. So this is a universal client from us. The client is basically agent or agentless software that sits on a user's, natively sits on a user's device, whether that's Windows or iOS or Android or Mac OS. And the client essentially operates in the background and dynamically is always there. So when a user wants to make a request, essentially it's the client that's reaching out to the controller in a secure way, because it's enrolled in a highly secured way. And it's saying to the controller, I'm here and I want to make a request. The controller then talks to the client and says, okay, let's check your authentication of your user. Let's verify your device. Let's verify what's running, all the critical things we need to have running in your device. Let's check your location and your time of day. It captures all these attributes and then compares it to a policy that's housed in the controller. And the policies will determine what applications, based on who they are, what they have, where they're located, what their role is in the organization. It automatically will determine what applications, or essentially gateways connected to the applications connected to the gateways, a user can directly communicate with. Once there's a green light, a policy is granted, access is granted, the controller then communicates to the gateway and says, hey, gateway, this user's device is going to be communicating to you in this trusted way. Be ready for it. It communicates to the client and tells the client in a secret way how to communicate directly to the gateway. And then direct communication then occurs between the client and the gateway. So what I've described to you is essentially the software-defined perimeter model in which you have a control plane, and that's all the control communications between the client and the controller, and between the controller and the gateway. And then essentially the controller establishes the trusted communication between the client and the gateway, and that is called the data plane. The way we've implemented is provides a lot of benefits. One benefit is, we reduced what's visible to that client, to that user, so that they can't, whether they're inside the network or outside the network, the only things that are authorized to see are what the controller provides them information to. So that's called dark cloud, and that's a big security benefit. So there's less attack surface for an organization to worry about. The second thing, which is a great benefit, is that of data sovereignty. So all the data and application information is we never see, we meaning Pulse Secure, never sees this information. That's all kept between the client and the gateway. So it really allows for a higher degree of data protection and data sovereignty. And the third thing is we talked before about manageability. So it's a much easier to provision and manage everything centrally, but it also allows for scale. If you look at other technologies, including VPN technologies, people have had to manage both the data and controlled plane information going directly through the VPN, which means the more connections you have, the higher VPN capacity you would need, whether that VPN is delivered through a next-gen firewall or through a dedicated VPN solution. But because since you're separating the data and control plane, it really allows organizations that much more easier to scale out, to distribute more gateways, beef up their controller. It basically allows for a much easier way to provision and scale.
Okay, machine learning, I guess, and the bigger picture, artificial intelligence. That's another sort of can't ignore, I suppose, in the digital world we live in. Can you just talk us through a little bit about that in relation to secure access management?
No, that's an excellent question. So one of the other benefits that I failed to mention was, if you keep in mind, the client is giving all this rich information, who they are, how they're configured, are they at a at-risk device? Should they not be allowed onto network or have limited access to network systems? When they logged in, has their role changed? Did they log in as a user for one application, but as an administrator for another application? All these things we capture and have all this rich analytical information of between the user, the device, the network resource, the policies, whether they pass or fail a policy, whether in or out of compliance, whether certain things have changed, whether their locations have changed. And so we capture all this information. We're able to have really detailed analytics through a really snappy GUI. So the administrator has all this information at their fingertips. But what we're also doing in the background is we've provided a means to apply machine learning or algorithms to understand what is a user's normal behavior, that user and that device, even other aspects of the system, and compare that to how they're operating today or how their other roles are similarly operating. And we can identify essentially malicious behavior or anomalous behavior. So every time they access and do things, we're applying essentially, the algorithm applies a risk score. When a risk score gets to a certain threshold, it'll notify the administrator to take some action, or it even can be incorporated into a policy to automatically take action. And so that's the power of machine learning being applied to secure access.
Excellent. I mean, we covered quite a comprehensive amount of issues around the secure access. Before we finish, I mean, is there anything final points to make? Or I mean, zero trust to me, I mean, I'm sure for you in working in the industry, it's been around a while, but it's a relatively new concept. There's that, there's multi-factor authentication. So I guess just any thoughts as to, whether these are worthwhile additions to the security landscape, if they get, got any longevity, or they're just the current buzz things which will, come and go.
Yeah. So I think, I mean, zero trust is all about a model as opposed to an architecture or buying a product that is just, you buy it and boom, you have zero trust. It's a model to say, verify everything before granting access or a transaction. And multi-factor authentication is a method of verifying identity. So that's a best practice. And you should have, depending on the the risk of the data that you're going towards, or the risk of the potential user, or the potential risk to the user that identity could be stolen, you'd want to increase the factors. That's why it's multi-factor authentication, but that just covers identity. So they could have show 5 forms of identity, but they still could be carrying something malicious through that gate. So you really also need to understand, okay, what's the security posture of that device for that user? In fact, it could be an entity. It could be an IoT device, not even a user. You need to accommodate things for the fact that they are, maybe they're accessing something simultaneously as different, using the same multiple credentials, but from different locations. Why is that happening? You need to accommodate for the fact that that user's role may change, or their device, something in their device may have been altered. Or now they're asking to go to, they've logged in, they're now asking to go to another level of a service. Shouldn't maybe another authentication be kicked off? So this is all about adaptive access control. And so that's one of the things why Zero Trust is not only here to stay, but will really evolve to a lot of adaptive security capabilities, is really to keep minimizing the risks and to automate systems to allow administrators to be faster to respond to potential threats or issues. So I think ZTA is here to stay. I think what's interesting is if you look at our solution, we're addressing the broader problem that a lot of organizations have, is how do I manage pockets of secure access, and how do I manage that for the broadest number of applications and the broadest number of use cases. So I'll give you a very quick example. So for example, a lot of users were physically on site operating systems that only were available on site, and now they were brought off site working remote in their homes, or now they want the customer, the organization wants to provide more workplace flexibility. How do you ensure that same level of responsiveness and same level of access? And so in many cases, even that, for example, for troubleshooting, goes beyond just going to a particular application. There may be times when you need to get to the underlying operating system or the underlying network to do troubleshooting or to do management. And so that goes beyond layer, now we're talking having access with layer 2 access, layer 3 access. So in other situations, you may have an install base of VPN users, and you may only want to have certain types of users that have access to cloud applications or other applications, and that you may want to do an SDP approach for them. How do you marry all these worlds and all these conditions, and how do you consolidate your secure access so it's more economically beneficial, it's easier to manage, and more efficient? And that's really what Pulse Secure is all about. So we're one of the few vendors in the industry that have not only a full portfolio of secure access solutions for network access, remote access, perimeterless access, but it's easier, it's from one place, we cover the whole spectrum, so you're not continuing to buy pockets of things that you have to manage. You can all manage it centrally and efficiently. And so I think that's where the industry is going towards: one, more cloud delivered security, and two, a consolidation of security tools and controls so they can really reduce risk and get more operational efficiency.
Okay, well, I really appreciate your time today. Thanks very much, Scott.
Thank you.